So in this video, we're going to take a look at question 15 from our first packet. And question 15 is in the section of proportions. Remember that a proportion is just an equality of two rates or ratios. So two ratios set equal to one another. So what questions 15 through 17 are trying to emphasize to us is how we can take a statement written in words and actually write a proportion mathematically. So remember that a proportion, since it's just the equality of two ratios, basically what we're trying to do is identify what the two ratios are in the problem. So if you look at problem 15 here, 7 is to 8. If all that was written there was 7 to 8, we would know that that was a ratio, as 21 is to 24. If we just looked at the 21 is to 24 part, we would know that is a ratio. So what we're really trying to actually do here is to identify what the two ratios are, write them as ratios. So 7 as to 8, since the 7 is on the left of the keyword, it will go in the numerator, the 8 will go in the denominator. In a similar fashion, 21 is to 24 will be written as 21 divided by 24. And since this is a proportion as indicated by the keyword as, we're just going to set those two things equal to each other. So what we've done here in this first step is we've translated a proportion written in words to a proportion written mathematically. Now the question, we weren't asked to do this, is can we show that these two fractions are actually proportional? So hopefully you remember from lecture that the way you show that fractions is proportional is to take the cross products along the diagonals and to see if they're equal to one another. So if we were to take the cross product on the downward diagonal, I'd be multiplying 7 by 24. I'm going to keep those in parentheses to show the multiplication, and we'll see why I choose to do that in a minute. On the upward diagonal, we have 8 times 21. And if we compute those two products, we have 168 on the left, 168 on the right. It's not surprising that the two things are equal because these two fractions are proportional. Another way that you can show they're proportional, if you want to think about it, is you can just show that they're equivalent fractions. They're the same fractions. Namely, if you reduce 21 divided by 24, then you would get 7/8. Or you can show the number that you need to multiply by in order to take 7/8 to 21 over 24. And hopefully you see when you look at this, hey, I can make the 7 into 21 if I multiply by 3. Well, if I multiply the denominator by 3, the 8 also goes to 24. So really, whenever I'm multiplying the numerator and denominator by the same number, I'm not changing the value at all. 3 over 3 is just 1, right? So what that is showing is 7 over 8 is equivalent to 21 over 24, which oftentimes you can do with simple kinds of proportions. So let's look a little bit. That was problem 15 at problem 16. Rather than having the actual proportion of two ratios, we'll have the proportion of two rates. We have the unit rate, $120 per day to rent something or buy something, whatever it may be, is proportional to $600 per 5 days. So we see that we have two rates here, $120 per day. The question is, what goes in the denominator there? Well, per day means 1 day, right? It's an actual unit rate. So $120 over 1 day is proportional to, we represent that with an equal sign. $600 per 5 days, we would write that as a rate is just $600 divided by 5 days. Now, even though when you're talking about rates, you traditionally carry around the units, since the units aren't the same, when you're showing that they're proportional mathematically, we can just kind of throw those units away before we do our cross products. So $120 per 1 day, we'll just represent it as 120 over 1. $600 per 5 days, we'll represent it as 600 over 5. If we check that these two rates are proportional by doing our cross products, on the downward diagonal, I have 125 times 5. 120 times 5, sorry about that. And on the upward diagonal, I have 1 times 600. And of course, 600 is equal to 600, which shows that these two rates are actually proportional. Namely, paying $120 per day for something is the same unit rate as paying $600 for 5 days of something. Finally, I'm going to let you try number 17, but we have, again, kind of a rate type problem that is often used in unit conversion. 3 ounces is to 0.1875 pounds, as 15 ounces is to 0.937 pounds. So I've shown you what the actual two ratios or rates here are. So you just need to set those up correctly. Put your 3 in the numerator on the left, put your 0.1875 in the denominator on the left, and have that fraction be equal to the fraction that you get when you convert what is on the right to a ratio as well. So that should give you a good setup through problem 17. And all that you're trying to do in 18 through 22 is also show that all of those proportions that you're given are in fact proportional. And the way you can do that is just through the actual cross product test, multiply the two diagonals and show that they're equal to one another.